I'm Alexander Hudek. I'm the co-founder and CTO of Kira Systems. We're a local Toronto-based machine learning company. And this talk is basically going to share our experience growing to what is now over 150 people in just a couple years, using Clojure as our main development language. So what the heck is Kira, you're probably wondering. So basically we do machine learning for contract analysis. And the typical example would be that if one company was going to buy another company, they're going to hire a law firm to go through the company's contracts that they're purchasing, and imagine it was a soft drink company, and that company's going to have contracts with their manufacturers, their distributors, and so on, like a bunch of them, employees, and every single one of those contracts you might have some language that says, well, if this company is purchased, I can renegotiate my contract, or maybe it falls apart, or who knows. So obviously the purchaser wants to know all this, so typically in the past they would hire a law firm, and the law firm would have a bunch of lawyers who are billing out at 500 plus an hour, and they're going to read some subset of these contracts. If you have many, many thousands, they probably won't read all of them, but you can see how this is time-consuming and fantastically expensive. Also, it's hard on the lawyers. They're often getting 4 hours of sleep a night and things like that. So what we built is we built a system that will read these contracts using machine learning and identify the things that the lawyers are looking for and say, well, this section of the contract tells you whether or not you can change it once you've purchased the company, and so on and so on. And so you can see these are the basic steps. You basically import your documents, you run a bunch of OCR on them, you run your machine learning on them, and then there's a very sophisticated user interface that we've built that lets the lawyers go through and analyze all the data, review, read the contracts, mark it up, and so on. So that's the short version of what we do. So the founding principles. First, we wanted to do fewer things but do them well. Especially in the enterprise space, it's very tempting to put all the features in because everyone demands all these features. If you do that without being careful, you're going to end up with, well, a lot of poor features. So we wanted to do fewer features but have them really be well done. We wanted a really good user experience, well-designed user experience. And of course, being a startup, we don't want to rebuild the world, so we want to reuse as much existing technology as possible. And then finally, we want to use the best technology, not necessarily the newest. I think there's a tendency a lot of people have to always run to the newest technologies. Certainly I have that tendency when I'm like reading Hacker News or whatever. Oh, what's this cool thing? But when you're trying to run a business, you have to be a little bit more wise and be careful with what you choose. So why then Clojure? Certainly at the time, Clojure was pretty new. This was 2011. I had been programming in Clojure for about 2 years, roughly, before founding. So why choose it if I just said that not to choose the newest thing? Well, one, it's functional. So of course, functional languages are very concise and you can do much more with fewer lines of code. To me, that means, well, maybe we could move faster. Two, it's immutable, very opinionated on being immutable, which is great for eliminating errors. Three, this talks about reusing technology. The JVM Interop was a huge selling factor. Being able to leverage the entire Java ecosystem is really significant. And then four, it attracts good people who are lifelong learners. I feel it necessary that everyone has to have a slide like this. Why didn't I choose all these other things? I actually really love Haskell. I think it's really neat design, and the way they use types is amazing. Although if Clojure has a steep learning curve, Haskell is more like the learning cliff, and I felt that might be bad for hiring people, and especially if you have to teach them the language. Secondly, it has a small ecosystem, and the interop just isn't as strong as Clojure's. Scala, I looked at Scala. It was very popular at the time, still is very popular. I just felt that it wasn't opinionated enough. I was really drawn to Clojure for being strongly opinionated on things like immutable data structures and whatnot. With Scala, you could write it in very many different styles. It could be very Java-like, it could be very functional-like, but I would really wanted something that was strongly functional. Java, well, I won't talk too much about that. Too much boilerplate. Basically, I didn't really want to be writing tons of factories. And then things like Ruby and Python, these are all excellent choices, but given that we were going to be doing data-heavy stuff, I felt that they were probably going to be too slow. So what did we end up with? First, before I go through the rest of the stack, I think being a machine learning company, everyone's wondering, well, what the heck did we use for machine learning? So remember, always use the best tool for the job. At the time we started, there were basically no Clojure machine learning libraries. So we had to look into other areas, and the obvious ones are Java. There was a ton of Java ones, still are a ton of Java ones, but there's also a lot of C and C++ ones. And when you're talking about the core numerical routines, basically C is still the king for these things. Even when you look at ecosystems like Python, it uses C for a lot of its core number processing, and we can use C through the JNI. So basically, we chose to use Java and C libraries for our machine learning stuff because that's just what they were written in. However, we did use Clojure for all of the feature pre-processing and data preparation that we fed into the machine learning algorithms. So the initial stack when we were starting to prototype stuff and building the product looked like this. We had Clojure for the web server and the data processing, pre-processing. We used a bunch of Java libraries for various things. The front end was in CoffeeScript, which was interesting. ClojureScript wasn't really a thing at the time, or it was just starting out rather. And of course, as I mentioned, we used Java and C, OCR. OCR is just in C, and we used EDN for serialization because why not? By the time we actually got our first customer, we had switched to this. ClojureScript suddenly became a thing. So we were using ClojureScript with React.js underneath by Ohm. And then serialization, we quickly found that EDN wasn't quite performant enough when you're dealing with very large data structures, so we were using Nippy at that point. And that's how we, that was what it looked like when we got our first customer. And largely is still similar today, although we're making a few tweaks, which I'll cover at the end. So, how did it work out? Was Clojure a good choice? Did my thoughts on it come true or not? So, great things. I'll cover these in more detail, but yes, Interop was great. It felt very fast to develop on. It was an excellent hiring filter. But we had some struggles as we started growing as well. And there's a bunch of these, so let's go through them. First of all, Java Interop. Libraries like these up here, PDFbox, DocsX4j, the ClearNLP is a machine learning library, LibLinear is another one. You're not going to rewrite these things from scratch. I mean, it would be foolish to try. So this was super useful. Being able to leverage libraries like this was absolutely invaluable. Less code, yes. The REPL-driven development was glorious. We had so much less boilerplate than the corresponding Java libraries that we were using. So this was really, really fun. We were able to move really quickly, especially as a small team. When you have just a couple people that are always, in sync, that was a really good experience. And the hiring filter really worked at the start as well. It absolutely selected for strong self-learners. Anyone who takes the time to learn a language like Clojure, probably in their spare time, because they're likely not doing it in their day job. Certainly at the time that was more true than today. These kinds of people generally care about good design, and writing software the right way, essentially. And they're often polyglots as well. So this is all came true, and a lot of most of the applicants we had that were drawn because of Clojure had these properties. So that was really, really good. However, once we were trying to hire 10 or more at a time, it became a real challenge. So first of all, we had many remote applicants. We still do, or we started out having to have a lot of remote applicants as well. But remote applicants, as you become a larger company, starts to have more troubles around HR and whatnot, like you have to comply with certain laws in each country. You can't give benefits unless you have a local office. So it actually becomes quite a bit more challenging than you might imagine when you're growing a big team. And then if you're mixing local and remote, it becomes really challenging not to let your to keep the remote developers not feeling like second-class citizens once you have a big office, which we now do. We also find that there's a lot more junior developers than senior developers. And then by a large margin, Clojure developers prefer backend. Clojure script developers are like unicorns. You cannot find them. So these were real challenges, and they remain real challenges. So basically, and I always knew this when we started, but we have to teach Clojure. We've come to the conclusion we have to put out job ads that say, you don't have to have Clojure experience, you can be writing in whatever, and we are now just going to teach you. So that's something to be prepared for if you choose Clojure and then end up scaling quite quickly. So there's many ways to write the same thing in Clojure, which is really one of its strengths. It's super expressive, but this can also be a big challenge. In particular, when we started out, there was not necessarily as much best practice as there is today. There was nothing like Luminance, Luminous, yes. So we had to basically look at all these ring libraries and choose the best one, and it's okay, this one's not good, flip this component out, which is great, like that was really enjoyable, but it takes time, and that's not always what you want when you're trying to create a startup. You want to just get a product built as quickly as you can that works and is secure and performant. And then there's a lot of other things that can cause debates and arguments, like should you use a zipper or a simple assoc? Should you introduce a DSL via macros or not? And these things, everyone has their own preference. We all love debating them, but it ends up being a fair bit of a distraction. So that's something to keep in mind. It's not necessarily a bad thing. It's just something you have to, be ready to deal with as you. And then the more people you have, the more debates you're going to have too. So there's that. Which basically means that you need real discipline when you're growing a larger team size. You need to, really be careful about enforcing, standard good software development practices, like don't rewrite things that are working and tested, even if you really, really want to, because working code is very, very valuable. It's hard to do that. It really is. We all have that urge of looking at code and being like, oh, this thing is like awful, and I want to, rewrite it and make it glorious. You need discipline to really scale, and then, boring sometimes is best. So, short code is good, right? Who's been here before? You've gone back and you've read some Clojure code, and it's this super concise, tight line, and you're looking at it and you're going, oh my goodness, this is like really, really hard to parse, and you're pulling it apart and staring at it, and then 30 minutes later you're raging, you're like, okay, who the heck wrote this damn thing? And oops. Yeah, so it's interesting. We all like writing concise code, but writing concise code isn't always the best thing to do, especially when you expect that other people are going to have to read your code, or even you a couple years later. You should probably write longer code, but these are the things that we often don't talk about enough, but they come back and really bite you when you have a team size of 40 plus. Basically, readability to other people and you is more important than being very clever and coming up with the most compact way of writing something. So, some other interesting challenges that were probably unique to the time, certainly, but could still be an issue as well. So, libraries in the Clojure ecosystem back then churned quite quickly. They would fall out of favor or become deprecated. Great example is on the front end, where we had a lot of struggles. So we started out with Ohm, and then Ohm was abandoned. So we're like, okay, and what do we use now? There's Ohm Next, there's Reframe, there's ROM. So we spent a lot of time looking through all of these different frameworks to find the best one and figuring out which one is going to be well supported and is going to not be deprecated in 2 years or something. And in the end, we went to Reagent. But this took a lot of time, and rewriting our entire front end, first from non-ohm to ohm, and then from ohm to reagent, that took time. In fact, it was only just last year that we finally got rid of all of our ohm code. So just to give you an idea. And then there's similar things, like do you use Domina or Domi? Which one's supported? Are they actually abandoned? Who knows? Schema, then spec comes out. So these were challenges that were not ideal for a startup. Good for experimentation, good for testing out new ideas and things like that. But not necessarily good for a startup. Finally, this one surprised me. I never expected to run into memory overhead because everyone says, well, you probably don't worry about this until you have this problem. But well, we found this problem, and just to give you an idea of why we found this problem, is that we describe documents in very, very excruciating detail. So we'll have, for every single character, we'll store its location on the page. And when you have a 1,000-page document, which, yes, do exist, that adds up. That adds up real quick. So we started running out of memory on our processing nodes, and you did the usual thing, you bump your RAM up, but you can only do that for so long, and of course then your AWS bill starts going up and up and up. So the Clojure actually made this problem a little bit worse because the immutable data structures have actual overhead in terms of memory that becomes significant at this scale. So, the other thing, yes, balancing JVM heap with C++ memory. When you're using the JNI, they're two separate memory pools that fight amongst each other. And even if your JVM heap is not being used, it's still allocated, and that takes away from your C program and vice versa. So we had all these problems and then how do you solve them? Well, you could say, well, let's run one document on each node that has 16 gigs per document. That's wonderful, but now I'm using one CPU core, so that sucks. But if you run 4 CPU or documents on one node, great, we're using CPU, but if you get 4 big documents all at once, crash. So you have to balance these things, and it's really not simple. And then finally, I mentioned schema. So types, we can argue about dynamic versus typed languages basically forever. But I'm just going to talk about what we did. So we started with no types, and that was fine. But we noticed some bugs here and there that could have been caught if we actually had types. In particular, for some of our maps that would go into message queues or whatnot. Things like a typo in a keyword would be not detected as quickly as it could be. So we're like, oh, schema came along. This looks kind of cool, and I've always liked types. So we started experimenting with schema in select places, and that worked pretty well. We caught things earlier, which is what you want. The syntax was reasonably concise, and it helped document code too. Once you have a large enough code base, when you see some argument that says, doc, well, what is that? Is that text? Is that some big map? Who knows? But when you have types, that's one way of documenting it. You can of course use comments as well. So then along came Clojure.spec, and Prismatic, the company who made schema, they were gone, and so schema's future was basically unclear at that point, and spec being official, we're like, oh, okay, well, let's jump on the official bandwagon. So we now today use spec for all our new code. Every single function almost we write spec for. And as probably most of you know, spec is more powerful. It's great for generative testing, so there's like really good things about spec. However, it does give up a fair bit of conciseness, and there's still lots of debates about this. Should we write specs for every single function or not? Is it really necessary? And so on. We don't actually have answers, but this is just what our experience with it is. And then finally, as a bonus, let me just talk about the REPL a bit. Maybe this one's just me, but when I first started Clojure, I'm like, wow, testing in the REPL, this is the best thing ever. I can iterate so quickly. But what that led to was bottom of the file tests. And what is a bottom of the file tests? It's this thing on the right. That's actually from the core Clojure code. It's there to this day. You have your tests there in a comment block, which is convenient, but not good for having unit tests. Those things should be unit tests, right? And then you end up without the unit tests. and that comes back and bites you. So be careful about that. And then Clojure script REPL, I've used it once or twice, but I've never used it on a daily basis, and I polled our team, and most people also don't use it on a daily basis. A few do. It is useful, but I think it's the tooling, and there's other reasons why people don't use it. So that's our REPL experience. So what's next for us with Clojure? So Clojure and ClojureScript remain our core languages. And as I mentioned, we're now hiring people without experience in these languages. We're hiring for many, many positions. But what we are doing is we're introducing Go for the core data processing. As I mentioned, some of the serious memory problems we were having. One option would have been to say, okay, well, let's rewrite things without immutable data structures, and then my code's going to start looking a lot like Java with brackets on the outside. And I don't really like to write Java. Go had some other beneficial properties that it's you can cross-compile it easily, and the tooling is really fast and excellent. And then at the end of the day, the machine learning code is a lot of array access, and even our Clojure code looked a lot like loop recur with array accesses. So when you rewrite that kind of code into something like Go, it's not actually that much less expressive, it turns out. So that's one major change. So this is an interesting thing, just if people were curious how big our code base is now. This is lines of code. This is also a great example of why lines of code is a bad productivity measure, because as you can see, our Clojure script lines go down. That's because of the ohm rewrite. But our main application is continuing to go way up. We're at roughly 120,000 lines of Clojure, and then you can see the Go quickly jumping up there as the backend got rewritten into that. These are release numbers along the bottom. This is basically since the history of the company. Also, because now we're introduced Go, we needed language-neutral serialization, but there's other reasons for this too. So one of the things that we found troublesome was that we put our nippy serialized stuff into database blobs, which is fine, but then it made it hard to inspect. And in particular, something like Postgres, where you have native JSON types, it's really nice to be able to do queries on them or inspect them. So for that reason, we're moving away from EDN largely to JSON when we're using it for database things or serialization of that type. Neither EDN nor JSON are particularly space efficient. So for our very, very large data structures, we've now moved to protocol buffers. And protocol buffers do have some limitations, but they certainly satisfy the performance needs. So that's where we're going on our serialization formats. So our future stack looks like this. Clojure and ClojureScript remain the pillars, and the front end now is all in Reagent, which is wonderful. The serialization shifting over to JSON and protobuf. We have some Go in there. OCR will always be in C++ because that's what OCR's engines are just written in. And then if anyone was curious, as a bonus, our web stack looks like this today. Immutant is the web server. It's an excellent web server if anyone is looking for something to use. Postgres is a good standby for a database. Views is a library we wrote, so this does, when the database changes, it'll automatically propagate those changes up to the ClojureScript front ends, so that all of our interfaces are completely reactive. They always reflect the current state of the database, or, well, the state as of a little bit ago, right? The web client, as I mentioned, Reagent, Sente as WebSocket library, and that's what we use to do these dynamic updates, and Views is on both sides. Views is open source too. If you're curious about it, you can go to this URL. So finally, just some quick lessons and maybe some suggestions for how we can improve things for future companies that choose Clojure. So I personally think Clojure could be more opinionated even than it is today. stronger guidelines on being concise versus being readable. I've read some excellent blog posts on this, so there is material there. But if we had a louder voice as a community about don't write things too concisely and things like this, I think that would be really helpful for newcomers and new people who are planning to write large code bases in it. Also, guidance on how to structure large applications. As I said, it's such an expressive language that you can write things in so many different ways, but that can often lead to big hairballs if you're not careful. So, if there's some stronger guidance on how to do that, it would be very helpful. And also stronger messaging around when to use things like core.spec, macros. A lot of the time we just leave it up to people and say, well, it depends on the use case, which is certainly true. Though some basic best practices, like for macros, for example, it's don't ever use them unless you really, really know what you're doing. That's a really good piece of advice. But we should probably have a similar advice for other things. Is there a best practice around spec usage? I suspect in time we will come to some conclusions, but those kinds of guidelines are really, really, really helpful for newcomers who are just looking to get something done really quickly. So that basically means we should not be too clever. So in terms of some of these frameworks, as I mentioned earlier, stuff like Luminance is amazing. Secure defaults, that wasn't there when we started out. So I think more things along these lines are excellent. I'm happy to see that these are starting to become a thing in the community. Some library maturity, and this is something that certainly companies like mine and others have a big role to play in, but being formal about breaking changes would be really, really helpful. There are certainly cases where we've been stuck on a deprecated version with no easy migration path, or as I said, the libraries are like, okay, I'm done with this one, I'm going to write a new one instead of trying to evolve it. It's hard for companies, and I think if bigger companies sponsored libraries and stuck with them and were then it would be easier for new startups, because they can be like, okay, I figure this library is going to be with us for years, and it's probably going to be maintained and bugs will be fixed pretty quickly and whatnot. So that's one thing I think that can be improved, basically sticking with things and evolving them rather than always rewriting them. And then finally, if we rallied around some basic top libraries, that could be a good rule of thumb too. It's like, okay, there's all these choices, but pick X and just go with it, and then if you figure out it's not working, then change it. And I think those kinds of guidelines can be really helpful for new people too. And then finally, this is actually a bit of a learning from Golang, which has a really strong tooling. I think testing should be more first class than it is. Imagine if line uberjar checked your code for compile errors, ran a whole test suite, reported coverage, and it refused to produce a jar if anything went wrong. These kinds of things can really be helpful for a company. Like, we had times in the past where we compiled a jar, or we produced an uber jar, and it had code in it that didn't even compile. But we didn't ahead of time compile the thing at the back then. And we just didn't catch that until after producing the uber jar, and they're like, wow, okay, that's surprising. I didn't expect that to happen. Stronger linting could be really useful in consistency of code as well. And then, of course, I think we should be really, really much more vocal about people testing things in the REPL. It's like, just don't do it. Don't do it. When you're thinking the word test, get a unit test going. You can use the REPL for your unit test. That's cool. But testing in the REPL is not great. REPL's great for exploration, not for testing. And then, as the very last point is data interop. Probably we could be doing something better here. I love EDN, but it's not high enough performance for a lot of use cases. And then something like Nippy is unfortunately not very portable. So if there was some compromise, I don't know what it is, but that could really help for data heavy applications. And that's all I have. If there are questions, go for it. Yeah.
My question is basically You guys, you wrote a lot of stuff, right? Do you consider Cura technical debt free, legacy free by this point?
Is our code base legacy free? Is that the question?
Yeah.
No, definitely not. We still have a lot of legacy code. If you ask, we have a bunch of our devs here. You can probably ask them, and they'll tell you all their horror stories about things. I'm sure I'm in that get blame for a lot of them as well, which is embarrassing, but that's the way it is. So no, we're not legacy free. We have managed to rewrite some things, as I mentioned, but we still have, I'm sure there's still schema somewhere in our code base. For example, we haven't fully switched over. Our namespaces are still in a perpetual state of being, adjusted and fixed and things like that. Old code really sticks around. It's like stinky socks. It's really hard to get rid of. Yeah.
So Clojure is like very high velocity language, or it feels that way. Could you comment as your company has gotten larger and the engineering, like how much of that is attributable to it just being primarily used on smaller teams, which are also higher velocity? Like, have you noticed as the company's gotten larger, the velocity slows down a bit in the Clojure code base, and then especially when you start introducing new tools like Golang, which potentially have some more facilities for those larger teams, how did the trade-offs sort of play out in your mind?
Yeah, so it's absolutely slowed down as we've grown. And like part of that is just natural because a larger team is always going to be slower. But that's why I was mentioning that in that sense, the fact that it's so expressive is almost makes that problem worse because you can really spend a lot of time thinking about and debating different things, whereas something like Golang is in many ways, a very boring language, but it says, you know what, just do it this way, and I don't care what your opinion is, that's what the compiler says to do, so you do it. And that, I can see why they designed it that way for larger companies. How to translate that into Clojure, I don't know. That's why I think having senior devs on your team that can really give some discipline and be like, okay, well, let's, resist the urges to go and do X or Y and think about things in the right way. That's very helpful. But as I mentioned earlier too, it's harder to find senior Clojure devs.
And one more question. You mentioned that you're sort of switching into Golang for the core ML. Do you find yourself missing the interactivity that you were getting in Clojure, and also how mature is that ecosystem compared to the C FFI that you were doing prior?
So I certainly missed the REPL. There's no way around that. But the Go testing framework is so quick that it's surprisingly fine. It's not too bad. And then in terms of getting rid of C stuff, it's nicer to have it all in one memory model, especially if you're trying to do cross-compiling to different platforms. So we actually rewrote some of our C libraries into Go as well. Overall, I guess I like Go for machine learning stuff. I don't know that where it would fit outside of that, but for the core data processing, it's been a good experience so far.
Great, thank you.
So thanks for the talk. I have two questions that are connected in a way. So first, how do you advertise and hire people who are senior devs but do not know Clojure? That's the first question. And the second question is, let's say you need to hire 10 people. And let's say you hire 3 senior devs and 7 junior devs. What's that time frame between 0 and a year, for example, before you get, I don't want to use return on your investment, but before they become productive enough that you say, okay, he's a Clojure developer and he gets paid for whatever he does and it matches. What's that time frame? And the first question was about the senior and junior. Thanks.
So we're just starting on this journey of actually teaching people. Up until now, we've been trying to hire, people who already have Clojure experience. Although, it's finally this year it's reached the tipping point where like, no, we just have to hire for people without Clojure experience. So I don't know exactly how that'll work out in terms of teaching them yet. But in terms of hiring them, you just put the job ad out and say, we're hiring for a senior developer in whatever language, doesn't matter about Clojure, and then somewhere in the bullet points you'll say, yeah, you're going to have to learn Clojure. Obviously, if you can get people who have some functional experience, that's going to be helpful. In terms of ramp-up time, once you have a larger team, you're looking at months for even a junior dev, and you typically would want to integrate them into an existing group of developers rather than take a whole bunch of new people, put them all together, and then have them figure things out. Otherwise, it's just too hard to learn the code base and whatnot. So we don't typically hire 10 at one time. It's kind of staggered, and then we kind of feed them into existing groups until they learn learn enough of the code base that they feel that they're fully productive.
Okay, thanks. Yeah, once you have Kira in Clojure University all fleshed out, I would be curious to know what that course, how long that course would take.
Sorry, how?
Once you have your Kira Clojure University fleshed out, I'm wondering how long that course will take before it finishes, and they can graduate being Clojure developers. I'm just curious because we have a huge problem with hiring Clojure developers. That's probably the biggest problem we have.
Yeah, I know.
There's no Clojure developers. I know there's a lot of people in this room, but I mean we're in a bubble, and I just want to get out of this bubble and see how.
Jana, did you want to?
Yeah, that's a great book. Yeah, thanks. It's Clojure for Brave and True. It's the online book that you can. It's an awesome book. It's always updating, and it's a great resource. Yeah, thanks. Yeah.
I mean, if I had to guess on how long it takes to learn Clojure, I would say at least a year before you're really proficient in it, and I wouldn't even say that you're like excellent at that point. I know for me, even after 2 years, I was still. Certainly not beginner, but I was like far from a senior developer with 2 years of experience writing it.
So you were mentioning serialization frameworks,
yeah,
or whatever. Did you try like Avro or like binary JSON things like from Facebook or other places?
Yeah, there's a lot of good ones out there, and we looked at a bunch of them and evaluated a bunch of them. We ended up with.
I'm just interested in why you chose Protobuf.
Protobuf?
Yeah.
Partly because it integrates well with Golang, and then it's a good balance, right? Frankly, a lot of those frameworks are all excellent, and you could probably choose any number of them and not go wrong. But for us, it was like first of all, it's backed by Google, so it's pretty, that's going to be around a long time.
You sure about that?
Well, yes, I know they deprecate everything, but considering they use it internally for all their core stuff, it's likely to stick around. It had reasonably good support for various different languages, and those were the reasons. We were mostly interested in just 2 languages anyways.
Okay. Thanks.
Thanks for sharing your real-life story and a little bit of history of your company. I know we are at a Clojure conference, but just pretend the room is empty. If you were to start Kira system today, what stack would you pick?
That's a hard question. So, I mean, in general, if you're starting a company, I would say you pick whatever languages suit that company. If you're doing mobile stuff, for example, maybe you're choosing, something for that, like Swift or Objective-C. I don't know. If I were doing the same company again, certainly I like Golang on the back end, but I don't have experience with it on the web side, so I don't really know how well it would work there. Clojure, I really do like the expressivity, and I think doing it a second time with Clojure, I would probably be able to design it a heck of a lot better. Clojure script is the hard one, because as I said, it's just so hard to find Clojure script developers, and there I would be honestly quite torn between using something like TypeScript, just because finding them is literally like finding unicorns. It is almost impossible. We're now hiring just people with React experience, so it remains to be seen, though, how many of those people will be willing to learn Clojure script. I don't know, but that's the biggest challenge. So it's a non-answer in some ways, but it would certainly be one of the languages I would consider.
All right, thank you.